is for person 1 of project 2. For the laminar flow over a flat plate simulation, for part A, to find the velocity and pressure contours, you start with the fluid flow fluent block, and you put geometry and set it to 2D, and then you make the geometry of the flat plate. Where you have to go to sketching, make a rectangle with the given dimensions in the assignment, which it's supposed to be 100 centimeters in length. Yeah. So we can specify the dimensions of the rectangle we just created. Oh, we're in meters. And you have to make this a surface, so you create surface from sketches. Select your sketch. Apply. And generate. And make sure to update your geometry. And you can open up the mesh. Here, you should start by naming all of your edges for later use. So this would be the plate, and then you can see all your named sections. And for your mesh, you click mesh, or you go to face meshing, select your geometry, and then click generate. And you can see the first mesh, and then we are going to select sizing and the up, or select edges, the upper and lower one, apply the geometry, set capture curvature to no, and behavior to hard, and change the type to number of divisions. So we can just set it ourselves to something like 60, and then generate that mesh. And we're going to do the same thing almost for the inlet, where we have to set the number of divisions ourselves. However, we're also going to set the bias factor to 70, so later in the simulation, you'll be able to better see the boundary later at the bottom, and click generate. And you can see it's populated, and we have to do the same thing for the other side to Sizing. Apply. And select the same bias and bias factor, except here you're going to reverse it so that it mirrors the same bias as we did on the inlet, and generate. Now you can see the mesh has been made and generated correctly, where towards the bottom there's more, it's more specific, so you can see the boundary layer better. And then we're done with that, so we can update the mesh. And we close this over here. And now we can get started on the setup. And select double precision and start. Now that that has loaded, we can set the flow to laminar, like it says in the problem. And then for the actual fluid, it's set the density to 1.2 and the viscosity to 1.8 as specified from the project. Yeah. And save that. And for the boundary conditions, we have to make sure the velocity is at 2. After we've set the velocity for the inlet, make sure the plate is set to wall, the outlet. However, set the upper dimension to symmetry, so it acts in the same way as the plate. Set the method to simple and go to the initialization. Make sure that, I don't know why the y velocity is set to a value at all, but yeah, the x velocity is 0 and the y is nothing. Also make sure that this is computing from the inlet. After this has been initialized, you can go over to run calculations and pick your number of iterations for like 10,000 or something, and run it. After that is computed, we can start with part A for computing the velocity and pressure contours. For the velocity contour first, we have to go to contours, make a new one. And then select velocity and display, close that, and you can make your velocity vectors. Doors, same thing to display, and then to show them, you can open up C and just velocity. select both of them, save and display. We could make it transparent so you can actually see everything. And then you just screenshot this. And this is your velocity and the vectors for the contour. After you save that screenshot, you can start with your pressure contours, which for that just be pressure, static pressure, and then this is the static pressure contour. And then it's the same thing for the dynamic and the total. After you've done that, you can close your contour and get started on your velocity profile at the 35 and 75 centimeters, if that's what it was. Yeah. So you go to surfaces and add a new line break. You can put X35 that one. And for the X35, just do the same thing. You're done with that. Must be there. And then for the plot metric, and then you plot, you're able to see the velocity profile at the different points that we just made. So the points get the velocity. Make sure you select the two lines I just made. You can save the plot. And you can see that the two different lines are the two different points, and that the 75 has a larger boundary layer before it stabilizes. That is it. I just have to rip this file before I start up that. That is it for the velocity profile, two different points with the boundary layer thickness. You can see the velocity profiles are here. And this gap would be the difference in the boundary layer. And I'll see it in the data once I have it.